All right, here we go. Next unit is on angle relations, and today you're actually going to hear all of the angle relations that I need you to be aware of. All right, so you should be able to identify pairs of angles formed by a transversal. You should also be able to identify complementary and supplementary angles. So again, most of you should know that a 90-degree angle is known as a right angle, which is what's pictured here. This is a 90-degree angle. Now, if I take that 90-degree angle and I divide it, and it doesn't really matter how I divide it, okay? So if I just draw a line right here, well, if the whole thing's 90 degrees, then this top part and this bottom part right here should also still add up to 90 degrees. Okay, so it's kind of like if you have a cake and you cut the cake in half, you still have the same amount of cake, you've just divided it into two pieces. So again, no matter where I put this line right here, this is always going to add up to 90 degrees if we add the two, the little angle and the big angle together. Okay, so right here it's showing you what complementary angles look like. So this red angle plus this blue angle have to add up to 90 degrees. And again, that's because they're complementary angles. They don't have to be right next to each other. So if I said we have a 37-degree angle, what angle would I need to be complementary? You would just subtract 37 from 90. But again, that's not today's lesson. This is just on identification of these angles. So again, in our class, almost always your complementary angles will be right next to each other. And again, we know they're complementary because underneath here we can see that little box in the corner. You should also be familiar with the straight angle. It looks just like a straight line. Okay, they're actually not any different. A straight angle measures 180 degrees. Okay, so when they say you did a 180, that means if you were pointing to the left, you're now going the complete opposite direction. Okay, when they say you do a 360, well, then you'd be right back to where you started. All right, so just like that previous one, if I took this and I drew any line, and again, it doesn't matter, let's go with orange. It doesn't matter where this line is drawn. Okay, so right there, if I look at the left side and the right side, okay, again, that has to add up to 180 because this whole thing is 180 and all I'm doing is dividing it into two parts. So again, no matter where I'm pointing this orange line at, okay, both the left side and the right side angle must equal 180 degrees. Okay, so again, this is what it's showing you. It's showing you that these two angles are supplementary. So right here we have a straight line, and then we have a line coming off of it. So this purple line and this green line must equal 180 degrees if we add them together. All right, now what we're going to do is we're going to take two lines and we're going to allow them to cross each other like an X. And it doesn't matter how steep or not steep these lines intersect each other. So they might look like this. They could look like that. They could look like this. Okay, it doesn't really matter. They could look like a coordinate plane. Okay. Vertical angles is another type of angle relation. And what a vertical angle does, okay, it's the pairs of opposite angles made by two intersecting lines. So this one right here is on the left. Everyone should know the opposite of left is right. So D and B are vertical angles. Angle A right up here and angle C, so angle A is on the top. The opposite of top is bottom. So angles A and angle C are vertical angles. So it doesn't matter how I draw it. So again, right here, opposite just means skip one. The next one is the vertical angle. Okay, so this one and this one would be vertical angles. So again, if I mark this one, skip one, that is a vertical angle. And then this one, skip one, this is a vertical angle. So the red and the purple are vertical angles with each other. And one last example, just so you guys can, or I guess we could do two more examples. So again, if I'm talking about this side right here, skip one, vertical angle. If I'm looking at the top, skip one, these two are vertical angles. And then this one, skip one, vertical angles. So again, these two would be vertical angles. So no matter what, you should be able to identify which angles are vertical to each other. These ones are labeled so that you can clearly see, and you can read angle A and angle C are equal, and D and B are equal. All right, parallel lines are usually marked with little arrows. So again, that's these things right here. This is signifying that this line is parallel to this line. And there's these that signify that those two blue lines are parallel, and parallel lines are never ever going to cross each other. These four lines right here, these are all parallel to each other, and again we know that because they all have that little triangle arrow pointer thing. All right, so now we're going to step it up. We're going to take parallel lines, and again we know that these are lines are parallel because they're marked. And how we're going to draw a line that crosses them. This is known as a transversal. And you're going to hear that word a lot in this unit, so you have to know what that means. Now in our class, the transversal is only going to cross parallel lines. I'm not going to throw any trick questions at you, but that's not always the case. So a transversal literally just has to cross two lines. Okay, so that purple line that I drew crossed both of those green lines. So that's technically a transversal as well. But again, in our class, they're always going to cross parallel lines, okay, because that's what gives us the special relationships that we're learning about in this unit. Okay. So when a transversal crosses a pair of parallel lines, it creates several special relationships that we're going to be discussing in this unit. So the first one is our linear pair. A linear pair is a pair of adjacent angles formed when two lines intersect. Now it's important to know that adjacent means they're right next to each other. So if I'm talking about a neighbor that's adjacent to me, that's either the neighbor that lives on the left or the right hand side of me. It is not the neighbor that lives across the street or down the street and around the corner. Okay. So in this diagram, A and B are adjacent. Okay. They also have to be supplementary, meaning they add up to 180 degrees. So again, this red line is 180 degrees. So angle A and angle B are our first example of supplementary lines. Okay, I'm going to show you a separate diagram down here for all of them. So again, notice also on the other side, we also happen to have D and C. Right there, D and C are also linear pairs. So again, they're made up of a straight line. They share the side, and they add up to 180 degrees because they share the straight line. All right, moving on to this line over here. Okay, E and F is another example of a linear pair. Okay, so again, they share this side. They're made up of a straight line which measures 180 degrees. And then on this side, we have H and we have G. Those are also linear pairs. So again, they share this side, and they're made up of 180 degrees because they come off of a straight line. Now these are also still linear pairs, or just the opposite ones. So up on the top example, right up here, we talked about A and B. Well, A is also a linear pair with D, okay? Because again, they share this side, and they're made up of this straight line instead. So again, now we have B and we have C. So again, they're made up of this straight line, and they share this red line right here as a side. We also have E, which now can go with H. So again, there's lots of linear pairs in this diagram. So again, they're made up of this straight line, and they share this line as a side. And finally, last one, we also have G and F. So again, they share this side, and they're made up of that straight line right there. So in a diagram where there's two X's, so again, I call these X's right here, the A, B, C, D, that's one X. The E, F, G, H, that's a second X. So in any diagram where there's two X's, there's 8 pairs of linear pairs. They get shorter. There's not as many of the rest of them. So again, even in this diagram, we still have linear pairs. So again, remember in linear pairs, we don't even need to consider this side. So remember this one, skip one, A and C are an example of linear pairs. Okay, B, okay, skip one, D is a linear pair with B. If we go to the other one, we still have linear pairs over here as well. So E, skip one, E and G are linear pairs. And finally, in this diagram, there's only one more linear pair that we haven't marked. F and H are linear pairs. Okay, so F, skip one, H. And it doesn't matter which direction you go, F, skip one, H is its linear pair. Vertical angle, not linear pair. All right. We also have same side interior angles. So same side interior angles are two angles that are on the same side of the transversal. So if we think about this, this is kind of like below the transversal down here, and this is above the transversal right here. Okay. And they also have to be on the interior of the parallel lines. So if it helps you, create a box. Okay. So right here we're now in the box. So again, the only letters interior are C, B, E, H, and E. Okay, right there. So what we need it to be on the same side of the red line, and we need it to be inside of the box. So C and H is one example of same side interior angles. Okay, we also have B and E right there. Okay, so this is one pair, and this is the other pair right there. That's all there is. There's only two. Okay, notice just two. All right. If instead we're talking about same side exterior angles, well, most of you might notice the only word that's changed is exterior. So they still have to be on the same side of the red line, but now they have to be outside of the box. So again, same side exterior, we're no longer considering this. So we should only be looking at A, D, G, and F. So if we're on the same side, that means D and G are same side exterior angles. Also, A and F are same side exterior angles. So again, right there, there's only two of them in this diagram. Now, if we drew more lines, there'd be a lot more. But again, we're going to stick to nice basic diagrams. All right, here we have our alternate interior angles. So again, the interior means we're looking inside the box. So again, we don't want to consider any of that. Okay, so the angles have to be inside the black lines, which I just drew the box and I've crossed off all the extra stuff. They also have to be on opposite sides of the red line. Okay, so it has to alternate. Okay, this one. It also has to be on the opposite side of the red line. Okay, so this is on the top of the red line. The bottom of the red line is where you'd find its alternate interior angle. So it alternates two ways, okay? It alternates the parallel line that it's located on, so we jump from this one to this one, and it alternates the side of the red line that it's on, which also means we have a second pair of alternate interior angles, and that is C and E. Okay, so again, you'll notice right here the yellow highlighted part is going to become important in the next section. Okay, but right now you just need to know and identify what these words mean. So an alternate exterior angle, so again, if we create the box, exterior means it's not inside the box, it's outside of the box. Okay. So again, the same thing needs to happen. We need to jump parallel lines. So we're on the top parallel line, we're going to jump to the bottom parallel line, and we need to go to the other side of the red line. Okay, so A and G are examples of alternate exterior angles, and D and F are alternate exterior angles. So again, there's only two pairs of those. All right, corresponding angles occupy the same relative position at each intersection where a straight line crosses two others. So again, what we can think of, A is the top. This is the right-hand side, this is the bottom, this is the left. Or if you like, north, east, south, west, okay, depending, it doesn't matter, okay. Well, if we think about this as a completely separate little X, okay, the E is on the top, or the north side. The F is on the right, or the east side. The G is on the bottom, or the south side. And the H is on the left, or the west side. Okay, so again, it doesn't matter. So notice A and E have the same letter. That's because they're in the same position. So A and E are corresponding angles. Notice B and F are both labeled R. Okay, so those are corresponding angles. And then notice C and G both have the B for the bottom. And again, if you prefer south, that makes no difference, okay? As long as you understand that they're in the same position, they're just in different X's. And then finally, we have D and we have H. So right there, those are also corresponding angles. So those are all of the angle relationships that you need to be aware of.